Welcome to Daily Papers, the podcast where we break down fascinating new research into bite-sized conversations.
Today, we're diving into the mind of an AI. We all know there's incredible AI image generators like Midjourney or Stable Diffusion. You type in a prompt like an astronaut riding a horse on the moon, and out comes a stunning piece of art.
It feels like magic. It feels like the AI is truly creative. But what if it's not always creating? What if sometimes it's just remembering? And what if it's remembering things it shouldn't, like copyrighted images or even private photos it found on the internet?
That's the core question behind a new paper called Cyclic Denoising reveals ultra-stable memories in diffusion models. Researchers have found a new way to essentially shake an AI until its hidden memories fall out.
It sounds a bit like an interrogation technique for algorithms. So first, let's talk about this problem of memorization. When an AI is trained, it's shown billions of images from the internet. The goal is for it to learn general concepts, what a cat looks like, what impressionist style means.
Right, but sometimes instead of learning the idea of a cat, it just perfectly memorizes one specific photo of a cat it saw many times in its training data. So when you ask for a cat, it doesn't create a new one, it just gives you a copy of the one it memorized.
And this is a huge problem. That memorized image could be a family photo from someone's blog, a piece of art by a living artist, or a stock photo complete with a watermark. Finding these copied images has traditionally been really difficult. It's like looking for a needle in a haystack of billions of possible images.
Exactly. You'd either have to guess the exact text prompt that triggers the memory, or you'd need the original training data to compare against, which most of us don't have access to. But this new paper introduces a clever, prompt-free method called cyclic denoising.
Okay, let's break that down. First, we need a quick refresher on how these AIs, called diffusion models, actually work. The basic idea is that they start with an image of pure random noise, like TV static, and they gradually clean it up, or denoise it, step by step, until a clear image emerges.
Think of a sculptor starting with a rough block of marble and slowly chipping away until a statue is revealed. The AI is the sculptor, and the noise is the marble. Denoising is the act of chipping away the noise to reveal the picture underneath.
So, cyclic denoising takes that process and turns it into a loop. The researchers start with an image, any image, and they add a little bit of noise back in, not enough to turn it back into complete static, just enough to make it a bit fuzzy.
Then they ask the AI to clean it up again, to denoise it back to a clear image. And here's the crucial part. The cleaned up image from that first cycle becomes the starting point for the next cycle. They repeat this process, add a little noise, then denoise it, thousands and thousands of times.
It's like a stress test. Imagine you have a photograph. If you keep smudging it and wiping it clean over and over, you'd expect the image to degrade and fade away into a blur eventually. And for most images the AI generates, that's exactly what happens. They just dissolve into nothingness or some generic bland pattern.
But, and this is the aha moment of the paper, some images don't fade. They are incredibly, almost stubbornly stable. No matter how many times you add noise and ask the AI to clean it up, the exact same image snaps right back perfectly. The paper calls these ultra-stable attractors.
The best analogy they use is a landscape with deep valleys or basins. Imagine you're rolling a marble around on this landscape. Most of the landscape is flat or has shallow dips, so the marble just wanders around. But if it rolls into a really deep valley, it gets stuck there. You can shake the board a little, but the marble just settles right back to the bottom of that valley.
In this analogy, the marble is the image being cycled, and the deep valleys are the AI's memorized images. These memories are so deeply ingrained that the cyclic denoising process can't shake the image out of them. It just keeps falling back into the same memory valley.
And the results are wild. The paper shows one experiment where the process starts with a random picture, but after a few cycles, it locks onto an image of a living room with a yellow chair. It then generates that exact same living room for over 2,000 cycles in a row.
Then, after 2000 cycles, it hops out of that valley and into a new one, an image of a different room with a white couch. It gets stuck on that image for another few thousand cycles, and a reverse image search confirms these aren't just random rooms. They are near duplicates of e-commerce and stock photos found on the web, which were almost certainly in the AI's training data.
It's like we're watching the AI's stream of consciousness, and it just keeps getting stuck on these powerful, ingrained memories. And what's really cool is that the researchers can control what kind of memories they find.
Right, they have a control knob, which is the amount of noise they add in each cycle. They call it the cycling amplitude. If they add just a tiny amount of noise, a gentle shake, the image only settles into very shallow, simple attractors, like a plain color or a simple logo.
But if they crank up the dial and add a lot more noise, a much more violent shake, it forces the image to escape those shallow traps and explore the landscape more widely. And that's when it finds the really deep valleys, the complex, high-detail, fully formed images that the AI has memorized.
So why does all this matter? Well, it's a powerful new tool for auditing AI models. It allows anyone to test an AI from memorized content without needing special access or information. You don't need prompts, you don't need the training data, you just need to be able to run this cycle of noising and denoising.
It tells us that these memorized images aren't just rare glitches. They are fundamental, stable structures within the model. They are features, not bugs, of how the model has learned to represent the world, and that has huge implications for copyright, for privacy, and for what it even means for an AI to learn.
It's a bit unsettling. It suggests that deep within these creative AIs, there's a sort of permanent, unerasable memory of the things they've seen. This new method gives us a map to find those memories.
A fascinating, physics-inspired peek into the ghost in the machine. That's all the time we have for today.
Join us next time on Daily Papers.